Good day everyone, my name is Karen Billy Senior Palcarin from BSED Major in Mathematics Section 2A. My topic is all about problems in the foundation of mathematics. And basically, the objective is to discuss the problems in the foundation of mathematics. A foundational crisis is a celebrated affair among mathematicians and has also reached a large non-mathematical audience. A well-trained mathematician is supposed to know something about the viewpoints above, which are the logicism, formalism, and intuitionism, and about the Gödel's incompleteness. The early foundation of mathematics. Evidence that in 1899, Hilbert David endorsed the viewpoint that came to be known as logicism. It was the basic concept of mathematics, are definable by means of logical notions. Historically speaking, logicism was a neat intellectual to the rise of mathematics, and particularly to the set theoretical approaches and methods. They also said that the theories are of natural and real numbers can be derived from set theory. Dedekind approach on 1871 the algebraic number theory, his set theoretical definition of numbers, fields, and ideals, and the methods by which he proved results such as fundamental theorem of unique composition. But the influential algebraist Kronecker complained that Dedekind's proof do not enable us to calculate. His view was that this abstract way of working, made possible by the set theoretical method and by a concentration of the structures involved, was too remote from an algorithm treatment called constructive methods. Also, in around 1890s, Hilbert's work on invariant theory led to a debate about this purely existential proof of another basic result, the basis theorem, which state that every ideal is a polynomial ring is finitely generated. This early foundational debate led to the gradual clarification of the opposing viewpoints. Cantor's proof in set theory also became quite essential example of the modern methodology of existential proof. This early Around 1900s, Cantor continuum problem question in set theory, and with the problem of whether every set can be well ordered. His second problem amounted to establishing the consistency of notion of the set R of real numbers. The problem shows that R can be well ordered. Paradox and consistency. Comprehension principle is a set of all real numbers corresponding to the property of being an ordinal. There is the set of all ordinals. The principle has thought of us as a basic logical law. Zermelo-Russell paradox shows that the comprehension principle is contradictory, and it does so by formulating a property that seems to be as basic and purely logical as possible. Predicability. The book of Frege and Russell made the paradox of set theory widely known to the mathematical community in 1903. Poincare used them to advance his critical points against logical and formalism. His analysis of the paradoxes led him to the coin of important new notion, predicability, and maintained the impredicative definition should be avoided in mathematics. For instance, Richard's paradox, which is the one of the linguistic or semantic paradox, definable real numbers, because definition must be expressed in a certain language by finite expressions. There are only countable many definable numbers. We can write them in alphabetical order of their definitions, also called as lexicographic orders. Choices, a paradox. is logically self-contradictory statement or a statement that runs contrary to one's expectation, as important as the paradox, where their impact on the foundational debate has often been overstated. The crisis in a strict sense. In 1921, the mathematician Zeitgriff published a paper by Weyl in which the famous mathematician who has a discipline of Hilbert openly exposed intuitionism and diagnosed a crisis in the foundation of mathematics. The crisis pointed toward a dissolution of the old state of analysis by Browner revolution. Intuitionism idea that mathematics is a creation of the mind. Brouwer was not worried for, as he would say in 1933, the sphere of truth are less transparent than those of illusions. But Weyl, although convinced that Brouwer delineated the domain of mathematical intuition in a completely satisfactory way. Hilbert program. David Hilbert in the early part of the 20th century was a proposed solution to the foundational crisis of mathematics. When early attempts to clarify the foundation of mathematics were found to suffer from paradoxes and inconsistencies, Gödel's and the aftermath. Extremely ingenious development of mathematics allowed Gödel to prove that systems like axiomatic set theory of Dedekind piano arithmetic are incomplete. That is, there exist propositions P formulated strictly in the language of the system, such that neither P or negative P is probable in the system.